Hello again, everyone, and welcome to the Skeptic Hangout, the place where we sit back, relax, and chit chat about intriguing and sometimes controversial topics through the lens of skepticism. We have with us today Richard Gilliver from the Skeptic Takeout and Laura McGee from Unapologetically Me. We have back with us again our two special guests, Ascalon, who is one of our lovely ACA volunteers, and Kyle Brewer from his self-titled YouTube channel, Kyle Brewer, where he produces short and engaging videos on science topics. Today, we are going to be talking about astronomy, not to be confused with last week's topic on astrology. So, grab your English tea or your boring straight black coffee and join us as we discuss all that is, all that was, and all that will ever be. This is episode 36, Astronomy. All right. So before we get too far into the topic, I just wanted to throw out a quick reminder. Don't forget to take a moment to like this episode and subscribe so that you can catch all of our shows. And whichever platform you're using, if you want to, just go ahead and hit that bell, that notification reminder, so that you'll know every time we release a new show. Okay, gentlemen, astronomy. So last week we did astrology, and we had a difficult time with the astrology, astronomy, astrologer, astronomer. So, audience, bear with us if we have to say that word particularly slow to make sure we get it right, or if we happen to accidentally interchange the two. So I'm gonna once again let Kyle take this, because I just love putting people on the hot seat, especially my friend. And the more I like you, the more I'm gonna put you on the hot seat. There's a big, big difference between astrology and astronomy. So, for our listening audience, what is astronomy?
Yeah, so astronomy is the study of all things celestial, all things space, from celestial bodies like stars to black holes to planets to galaxies like our own Milky Way. Um, yeah, that's the basic rundown of what astronomy is. Just has to do with space.
So, guys, let's get this off the table really quickly because I know that we'll be delving back and forth into the two of them. We did this in astrology a lot, where there's a lot of crosstalk between astrology and astronomy. So, what are the differences or the big distinctions between astrology and astronomy? That way, we can get it off the table and move on to more interesting topics.
Oh,
Well,
one is science and the other one isn't.
I like
yeah,
it.
that's
Short, sweet, and to
the
the point.
biggest distinction.
So one is science.
That is pretty much it, yeah.
Yeah, one scientific observation and the other one is bullshit.
Mildly put.
Yeah,
Yes.
that was the actual word that went through my head. We've been doing this show too long together.
I know, right? We're gonna start finishing each other's sentences. It's gonna be really weird. Yeah. So astronomy to me has always been a really fascinating topic. And Kyle's videos touch a lot on these topics, like just the vastness of space, which is usually well beyond our comprehension. I say usually. I'm going to assume out there that there's that person that's like, well, I can comprehend the vastness of space. Good for you.
Not
Great.
a chance.
I can't. I mean,
Chance, no. There's a great Hawkwind song from way back when called "Space is Deep," and I think it's one of the greatest titles for a song that's ever been
literal
done.
and metaphorical.
Yeah, I think it's brilliant. Yeah. Talking about astronomy, I remember when I was really young, and we're talking about 9 or 10 years old, so we're way back into the last century. We visited. I'm not sure what county it's in. I don't know if it's Cornwall or Somerset, somewhere around that kind of little peninsula of England at the bottom.
Cornwall's not a county.
Well, whatever it is. Stop correcting me.
Leave that for the Facebookers.
I've lost a train. No, so I went. There's a satellite station down there, or there was back then a satellite station down there called Goonhilly Satellite Station, and they had a visitors centre, and we went to the visitors centre, and it was fantastic. It was brilliant. Learned a lot about, like I said, I was really young, and it really opened my eyes to kind of the technology that goes into observing space, which is, I think, sometimes something we forget about when we're talking about astronomy. It's so kind of normal now to kind of talk about it and understand it as what it is, which is viewing the heavens. But there's so much technology, and of course we don't just view it in the visual spectrum. We look at it with radio waves. We look at it with, we send satellites up there to have a look at it on our behalf, and a lot of these pictures, like this wonderful image we've got behind Kyle, are composites of lots of different methods of looking at space.
Yeah.
Put into one, whether it's infrared light or radio light, and that's all these fascinating images. Are not usually they're not taken from one photograph. The composites of, because these areas, that area behind Kyle, it's not just a few meters across in the night sky.
Light years,
We're talking
and
about
light years.
thousands of light years. The Horsehead Nebula is something ridiculous, like 30,000 light years. And if you look at it in the night sky, it's through a telescope, it's tiny, it's barely even perceptible.
And of course, we need to draw or make the distinction of a light year is not a measurement of time, but of distance.
Right.
This is something I went over in the last video I made, because a lot of people will hear light year and they think, well, how long is that? Like, well, no, it's a distance.
It's not a length of time.
Right, which is approximately 5 trillion miles per light year.
Give or take. That's a lot. That's 1 light year being that.
To break that down into something which is really incomprehensible, it's 365,000 miles a second. That's how far light travels in 1 second.
So that's a speed.
365,000 miles.
Yeah.
I do need to correct one thing. It's actually 186,000 miles per second.
Ooh, called out on his own podcast. Look at that. Actually, that's
so
kind of what we're
sorry.
here for. That's kind of what we specialize in, is putting things out there and then allowing people to correct us. Yeah. It's like,
please correct me.
That's probably one of our biggest strengths is we're wrong a lot. But.
You were right if you were using kilometers.
Kyle's allowed to correct me. Raymond isn't.
Ascalon isn't. Yeah.
Ascalon isn't. No.
Yeah, so what that means is the distance that light can travel within a year at that speed, that's what the distance of 1 light year. So it's kind of like the really, really, really big version of, say, like a mile or a foot. I don't think it's even comprehensible, like even how far away 1 light year is. So when we say that like this or that is 1 light year away, and I don't know of anything that's specifically that close, that is an incredible distance. Like mind-boggling distance.
Right. And even the closest star besides our sun is 4.2 light years away.
Yeah,
so
crazy.
More than 20 trillion miles.
Yeah. So that is where I think a lot of like lay people get into the astronomy can sound an awful lot like woo-woo, right? Like, how do you know for a fact that the nearest star is 4? And I know we have measurements and mathematical models and we do a lot of observations, but a lot of people don't know about the processes that go into astronomy. So if I were to hear, as say a spiritual person, like the nearest star is 4 point whatever light years away, my first thought, not knowing the process, would be, well, you just made that up, or how do you know that for sure, or how is that any different from my claims, right? Like it's kind of incredible.
Well, I guess the key difference is you can kind of go into detail explaining why we know this and give the active mechanism behind it. Unlike with when you ask an astrologist the mechanism behind their belief, you'd never come to anything as concrete as the scientific explanation.
Yeah. There's a lot of observation that goes into it that people just don't quite realize. I'm going to stop saying people and just say myself when I was religious, or when I was, I will say, astrologically or astronomically ignorant. I didn't realize just what processes go into discovering these different things and how much of it is just we think of if it's in a textbook, it's presented as a fact. But there's a lot that scientists say, well, we think this, or we're proposing that, or we have what's the word where you pull data out of other data, interpolate, like we've interpolated the data to mean this. But as we get,
Extrapolate, you mean?
what's that?
And extrapolate.
Extrapolating was the word I was looking for. Thank you. Extrapolating. So what we get, which I think is fascinating and incredible, but which a lot of people really have a hard time with, is we get best guesses that over time get refined and refined and refined. So science or scientists change what we know about the universe as we get new information, right? So it
Yeah,
changes
and
all the
I
time.
think it's one of those areas, not expanding from astronomy a little bit, but the whole study of the night sky is one of those areas that encompasses different disciplines of science.
Mhm.
So it's not just astronomy. You've got astrophysics, and you've got particle physics, and you've got all these different things which all combine, and cosmology. All these different areas of science combine to form the big picture. And you've got to remember, when you're looking at the night sky, we are literally looking, as far as we know, we are literally looking at everything that is. Everything.
Nope. We are looking at everything that was.
Yep.
Yeah, well, yeah, that's
Yeah.
it.
Takes that long to get here.
Yeah. So that I meant to bring up during the astrology conversation. I totally forgot. So you have the stars in a specific position, and then they produce some sort of like, oh, because of the energy from these stars and da 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 da, here's this horoscope. But what you're looking at in the sky happened billions and billions of years ago. So you're actually looking at what would have happened to your career or in your love life had you existed, 10 billion years ago. Because literally those stars are in completely different places now, and they have completely different properties, like some of which have exploded, or they've what do you call it? Not combined, run into each other,
Collide.
right? Collided. God, words are failing me for this this particular episode. So Ascalon will be my second half of my brain, and will be finishing my sentences for me.
I do have another quick correction there. Astrology isn't anything to do with the stars; it's the planets in the solar system. So, well, you're technically right.
Oh.
Looking at it from
Doesn't it have
Earth,
to do with
probably would be behind. But
yeah, but doesn't it have to do also with like constellations and stuff too, or am I mistaken? I don't know.
actually,
Yeah.
no, you might be right. Yeah, but the birth charts and things.
I
Yeah,
believe
yeah.
so.
Yeah. I don't know, but you are right that like they do speak a lot more on what the planet's movement is than what the stars' movement is. But I think stars do factor in there somewhere.
And I do want to make one small correction.
Yeah.
So when we look out into the night sky with our naked eyes,
Mhm.
all the stars that you're able to see are actually within our own galaxy. You need
Yep.
more complex imaging systems to view anything outside of our galaxy. In
That is
fact,
true, yeah.
the stars that we see are just a small little ring. This is just a little bubble around our central
Around the
area,
arm
our
that we're
planet.
on. Yeah, I wish I could put up a
Yeah.
graphic because you're right. When you're looking with your naked eye, not with satellites or advanced imaging systems, you have like this. So we have the Milky Way galaxy, and it's got all these little arms, right? And we exist on one arm of it. If you could draw like a radius, like a circle
Yes,
around what we can see, it would be just a very small part of that. So yeah, that is a good correction. Thank you.
no problem.
I that's one of the things I wanted to touch on, actually. The idea that the kind of the evolution of our looking at the night sky
Mhm.
from doing it with the naked eye to kind of the really phenomenal instruments we've got that help us do it these days, and like what that's meant to us as a race, and how it's expanded our knowledge over time and things, and the price that people have had to pay for it. There's obviously the famous case of Galileo was under house arrest
Mhm.
because of his interest in looking at the stars and some of the ideas he had.
Yeah, in our with what I'm teaching the kids right now, we just went over the heliocentric versus geocentric, both of which are wrong because the sun is also not the center of the universe, right? The sun is the center of our solar system. But one of my kids, we were researching Copernicus and Galileo, and I can't remember which one it was. I think it was Copernicus. Waited until he died, I guess, to publish some of his stuff because he knew that he would be persecuted if he published it while he was alive. And so we had a whole discussion on that. It created a whole sub discussion in our class about, it was more historical than less scientific at that point, about the worlds and the cultures in which these two gentlemen lived in, right, and how careful they had to be with what they said because it could bring on a death sentence.
Something you just said about the heliocentric model being wrong. Technically, from your perspective and anyone's individual perspective, when you look out into the universe, you
are the
are
center of the
actually-
universe.
You are the center,
Yeah.
yes. Because
Yeah.
wherever you are, your bubble.
You're looking at like a bubble. Yeah.
Your bubble shifts wherever you are. So basically, you are the center of the universe.
And that's just reminded me of a point. I'm a big fan of a show on astronomy on YouTube by Dr. Becky Smethurst, who's an astronomer. She's an astrophysicist, but a lot of her show is about astronomy. And she did a great explanation about the Big Bang. And this was the first time I'd ever heard it explained in this way. This completely blew my mind. It was like, and she explained it that people think the Big Bang happened somewhere out there and thing expanded out from that. But really, the Big Bang happened everywhere.
Because that's all that there was. Yeah.
that just completely blew my mind when I watched her. She's brilliant. If you're really interested in astronomy, I'd suggest, as well as Kyle's stuff, you go and look at Dr. Becky Smethurst's stuff because she's brilliant as well.
Can you? We'll get a link. I'll talk to you offline, and we'll get a link that we can put in the description for the listening audience. That we can, because I wrote that down in my notes as something that even I want to look into myself. But we'll add that so that people can check her out.
So this expanding idea that like we're constantly learning from observing the heavens. We're constantly learning more and more as time goes on and our instruments get better. So as the resident expert on the panel, I'm going to put Kyle's going on the spot a lot these last 2 weeks.
I don't know what you got yourself into.
No, not at all.
What? And of course, Ascalon can answer this as well. I'm interested in both sides of both opinions, and Laura, of course. What do you think, from your perspective, is let's say in the past 100 years, is the greatest invention that has aided us learning us about looking at the night sky? Barring the telescope.
Oh, damn, that was my answer.
No, barring like the basic telescope, which was an easy answer. That's why I said the last 100 years. So something that's...
Take that out of the table, yeah.
I'm not sure what Kyle will probably know the name of it, actually. I couldn't honestly tell you what the machinery is actually called, but it picks up, I don't know is it radio waves or emissions of radiation rather than actually something visual. It's going to annoy. I'm going to have to look that up.
Yeah, there are radio telescopes that observe the night sky.
I think my answer would be the laser beam.
Oh, interesting. And what's your reasoning behind that?
Well, for example, we know how far the moon is based on these. What you can do is you can bounce a beam off the moon and have it return to Earth and calculate the time it took and since we know the speed of light, we know exactly how far or how long it would take. Therefore, we know how far it is away.
Am I right in thinking that's bounced off an actual reflector, which was left there by one of the Apollo missions?
Yeah, and that
just wanted to check
awesome.
That fact.
Yeah, that is cool, and that's not something that we can do right now with planets, let alone stars. But it's cool that we're getting there. Yeah, imagine when we start going to Mars and we can do stuff like that, like with Mars.
And oh goodness, I'm forgetting the term. It might be spectroscopy that I'm thinking of, where we're able to look at stars, observe them, and tell based on the light shifting what it's made of and how far away it is, based on light.
When you say light shifting, you're talking about that redshift thing, right? Where we can tell what direction.
Redshift and blue shift. Yes.
Yeah.
And of course, the chemical makeup. If there's that basic kind of really basic scientific experiment when you get little bits of elements and lob them into a fire and they change color, and that's actually that's actually used in spectrop. That's
Yeah,
what
that
Kyle
one.
said.
Yeah.
and to determine what extraterrestrial planets makeups is actually done by looking at the colors and seeing the chemical makeup of them.
Yeah,
The atmospheres.
That is something that I found super fascinating when I was starting to teach my kids about like just the really beginner astronomy, which I think we've already kind of gone beyond what you would normally learn in elementary school. I'm pretty sure. But is that we don't just take pictures with a camera of the planets and the stars. We use these other data collecting devices that take in, and I'm not going to try and say that word that Kyle said, but that try to take in whether it's radio waves or radiation or their chemical signatures, and so they assign a color. So when they get these things back, they get data, not a photograph, but like data, and they assign a color. And so if it's like got copper in it or iron or zinc or whatever the case may be, it's assigned a certain color, so they can start building these pictures of these planets, and they can kind of tell what they look like because of their chemical signatures. And like I showed them the picture, it almost looks like what do you call it? It almost looks like the DNA thing, but it's a chemical DNA or a spectral DNA where it has the different where each element falls on the spectrum, like what image it makes, and then they're able to determine what element is in that specific star or whatever.
There's a really cool documentary. I think it's on Netflix, but I'm not 100% certain. And it's all about the first image they took of the first black hole they took an image of,
Ooh,
which was
nice.
not too distant in the past, a couple of years ago, I think it was something, maybe even not that far. And it was going through, and it was there were kind of various stages to this documentary. One was when they'd got groups of scientists talking about kind of putting theories together and exploring ideas, and there were like little bits with Stephen Hawking on there before he passed away. And then but the kind of bulk of the program, the push of the program, was actually forming this image, and it showed you these different teams they had in different disciplines, again, of science, who were actually working on getting this photograph together using this data. They were building up a picture from simply data and interpreting that data, and they had different teams interpreting the same data and seeing like what results they came out with. And of course, we've all seen the end result, which was the first ever image of a black hole, which was, but the look, if you have a look at the newspaper headlines, you'd think they've taken a photograph of a black hole, but when you actually watch that documentary, which documents it, it's so in depth and advanced and mind-bogglingly complex. You've got literally the best minds in the world from different disciplines working on that one thing.
Yeah, it's incredible. Well, that kind of brings up, I think I was kind of touching on it earlier, is that like we really assume when we see pictures like the nebulas or different galaxies and stuff, we assume that it's like a photograph that, like, I don't know, the Hubble took or something. We have so much scientific ignorance out there just within the general populace, which makes sense. I mean, not everybody is an astronomer, and we're not all going to study this, but it amazed me just how ignorant I was. And I'm still incredibly ignorant. Like, I wouldn't even call myself an amateur astronomer. I would just say I find it interesting, right? Like, I know very, very little. Yeah, I watch documentaries, and I think they're like wicked awesome. But like, the pictures are not pictures that we take. We gather data about what signatures are coming back, and then we turn it into a picture with computer modeling and stuff. And I just think that's fascinating. And I think in some ways it actually produces something that's more true to what's out there than what a photograph might take, in the sense that it's got more information within it.
Yeah, and I think something that a lot of people sometimes don't realize is just the sheer scale that these photos represent. I mean, you get flat earthers because the photos of Earth that we have, most of them are not just one picture. It's like you said, it's a stitching together of several images to create this one composite image. So they say, well, why isn't there like one whole picture of the Earth? Because the Earth is huge.
Even from the moon, they could only get a sliver, or not a sliver, but they can only get a portion of it, right?
Well,
Like,
that
wasn't it like
famous
it's
photo with the moon or the Earth rise over the
rising?
moon.
Yeah.
That was I believe one photo.
Oh,
I
okay.
think I could be
Yeah,
wrong on that.
I think you're right.
Yeah.
I believe that to be the case.
And it's still like, I think it's like a little portion of the Earth though coming up. And I'm sure maybe you probably could get. Well, that would be a good question. Could you get from the moon? Could you get a full picture of the Earth with a wide enough lens? I don't know. But anyway, you can't just do it from the atmosphere, like where we have
No.
the satellites and
Not a
astronauts
chance.
flipping around. Yeah, you can't do it.
But I mean, you only have to look at edge of Earth orbit to see the curve is still very, very small.
It's mild, yeah.
You know, if that's the better word, mild, yeah. When you're looking from even like near Earth orbit, of course, William Shatner's just been up, and there's several images of him looking out of the window at the curve. And despite what you think about someone famous spending millions of dollars and on something which could be argued is not entirely necessary when there's lots of people to feed down here, then
Yeah.
you know, despite that, it's still a fascinating thing to see people going up there. And you know, the guy's nearly 90 and is been on the edge of space. That's fascinating. That
Side
to me
note.
is fascinating.
Side note: my girlfriend was actually in the same room as William Shatner just a few days ago.
Wow.
She was at Comic-Con here in Indiana.
No way.
Yep.
He was. I mean, I know
So-
she was there, but like I didn't know that he was there. So that's cool.
She almost got a picture with him, but it was like $100, and she had already spent enough on the little gift she got me.
Aw. Yeah. I don't know that.
Too much.
What's that?
So 100 quid for a picture is just ridiculous.
But for the oldest man in space, I would do it.
I mean, now he's not just. What's that?
I'm saying, had he been to space at that point?
Well, I guess technically it's not exactly space, but I would be the pretentious bastard that would always say,
Close
well,
enough.
technically
Yeah.
we're always in space. You know?
Yeah, we're all astronauts, aren't we?
And where the edge of space is, of course, is a contested issue in itself. It's not something that's agreed upon by all the experts in the field. It has different definitions.
Yeah.
Of
Yeah,
where
Okay,
the
so
edge
that-
of space is.
Armstrong limit.
Yeah, so that brings up a question that I have right before, because now we're going to go to commercial break here in a second. But when we say that the space is 14 point whatever 8 or whatever billion years old, and what I heard when I was listening to Neil deGrasse Tyson was that, well, that's the edge of what we can see. That's the furthest we can see into space is 14 point, I think 3 or whatever billion.
Well, not quite.
Right, so that's where I get
13.
confused. I get confused. Is it extrapolated backwards with math, or is it pushed out forwards what we can see? And if it's what we can see, is there potentially something else beyond it? I mean, I have so many questions about the age of the universe and how it's. And
Well,
I've had it explained to me before, but it's complicated.
the universe is around, at least for our observable portion, is around 14 billion years old. Yes.
That's what I mean, yeah.
However, it is around 90 billion light years across because of the rapid expansion of space by dark energy. Dark energy is this force
That we
that
don't yet understand.
we don't know what it is. There's no sugarcoating it. We don't know. All we know is that it is expanding the universe faster and faster and faster. So while it's 14 billion years old, it's 90 billion light years across because of that rapid expansion.
So let's go to
that's fine.
commercial breaks. And when we come back from commercial breaks, let's talk about the horizons of the universe, those points that we can't see beyond. And we'll discuss that when we get back. What have we got coming up? If you watched the non-profits last week, you'll have seen us two, that one, that side, whichever side she's on to me. Hosting together for the first time, which was great. It wasn't the first time we'd worked together, as I incorrectly said last week, because we'd been on the secular parenting special on Jenna Mew's channel on if If Was, which is a fantastic channel. Go and look at that and subscribe to that. And we're going to be on that regularly if everything works out. So on the 1st of November, my own channel is having its birthday party. A live stream produced by the very, very wonderful Ethan Michael. It's going to be starring these 3 wonderful people who are all kind enough coming to celebrate with me. And Ascalon's probably just going to rib me all the way through it. I expect nothing less of him. That tends to be what our relationship consists of, me being nice and him being nasty to me. But there's going to be a whole host of wonderful people on there. We're going to have Cynthia McDonald, we're going to have Jenna Mew, Martin Robert. Oh God, there's so many people. I can't even remember everyone's name. So many people coming to help me celebrate the first birthday of my channel. Please go and check that. Laura, what have you got coming up?
Okay, so this last weekend I just did the nonprofits. So check that out if you didn't see it. And then I have it up again. We have a Veterans Day episode. So that will be premiering on the 14th. So Veterans Day is in the middle of the week. It's gonna be the following Sunday. But that's gonna be a really cool episode. So everyone check that out. And then like I said last week, we've got stuff in the works for GenMU's channel. I know Richard just spoke on it. And then I have some stuff in the works for the Promethean Secular Frontier. I know that I will be on the 1st, November 1st, Monday, November 1st, which should be next week after this particular episode airs. So catch me on that. And that's all I've got going on. What do you gentlemen have going on, Kyle and Ascalon?
Well, just be on the lookout for a few new space-themed videos coming out soon. Other than that, there's not a whole lot planned, but you never know.
And be nice on Facebook or he'll delete your posts.
For those who don't know, Kyle's one of
moderator.
the Facebook moderators for the ACA fan groups. So that's what Laura's referring to. We've got a good team down there. Actually, everyone here except Laura is a moderator for the ACA fan group. So we've got a lovely little team down there.
I'm a moderator in chat, live chat. I'm just not a moderator on Facebook.
I'm a moderator on both because I'm hugely important.
You're just like one of those I do everything kind of guys. He's just anywhere and everywhere. No.
I'm just a Facebook mod because I don't have a computer. I am only using a phone.
Oh, nice. Okay, I didn't know that. Yeah.
Yep, all my videos are recorded with a phone.
All Kyle's videos are absolutely fantastic, by the way. You should go and check him out. We'll put a link in the description. I absolutely love watching them. They're just the little short snippets. They're easy to digest. Fantastic language. He's got a soothing voice as well, which helps. So.
He's just blowing smoke. Don't listen to him, people.
No. Subscribe to him. Don't let him be modest. And also, it's funny because this is the astronomy episode, and that's exactly what his subjects are. They're all based on space and stuff like that. He just did one on like light speed and all kinds of different topics. So check him out. And I will put a link in the description to make sure you guys can find his stuff. And then Ascalon, I know that you volunteer a lot for the ACA, so I'm going to put you on the spot and have you kind of give a quick little plug for the ACA and what they've got going on and how you fit into all of that, like what you do to help.
Well, I mean, I have to, of course, mention vagina if we're talking about the ACA.
Just get that out of the way. Yeah.
But yeah, man, there's loads of stuff going on. But generally, you won't see my presence on the internet unless Richard drags me out of my cave. If you do happen to notice my presence on the internet, you've probably done something bad.
Because he works in the background, yes. But yeah, he works hard for the ACA, so check their stuff out if you're not. Most of our listeners are ACA followers, but if you're new to us and haven't heard of them, check their stuff out as well. Okay, so I guess the only thing we have left to discuss before leaving commercial break is the Facebook page.
Go and join our Facebook page, our fan Facebook page. Have a conversation with us. We link all the episodes up there. You can talk about the episodes, correct us when we go wrong, which we have been corrected several times during this episode by everyone. But that's what we welcome. We want you to correct us if we're wrong. When not above being corrected, we know we make mistakes and we want you to correct us. Go correct us, go watch us, agree with us if you agree with us, disagree with us if you don't. and let's get some conversations going around the subjects we're having. They're all fantastic discussions, and they do not end when the shows end.
Hey, welcome back, everybody. Okay, so before we left for commercial break, we were talking all about the vastness of space and how very, very, very little Richard and I actually know about it. But moving forward, before commercial break, Richard brought up horizons, and that can mean different things. So I'm going to let Richard kind of take it and reintroduce what your question was.
Yeah, I know very little about this, so I'm going to rely heavily on Kyle to prop me up here. As far as I'm aware, we were talking before the commercial break about the age of the universe being, I think it's something like 13.8 billion years, give or take. But the size of the universe is far greater than that because of the expansion of the universe. So there's stars in the universe which we will never be able to see because they're expanding away from us faster than the light will ever get to us. So we will never see. And I think they're referred to as horizons. I don't remember the names of them, but I think there were 3 of these horizons that expand out on, and they all represent different areas of what we'll never know. I think the first is simply the one where the light will never reach us, and I think the furthest one is something ridiculous, like just space will never ever be able to know or understand because it's expanded that far away from us. So I'm just interested in what your guys' takes are on that. If you know anything about it, if you do, can you expand on it? If you don't, what is your opinion on it?
Well, you're right. There are places in our universe that are so far away and expanding at such a fast rate that we will never, ever know about them. It's to say it's an understatement is a huge understatement. So we have what's I'm forgetting the exact horizon name of it, but we have the edge, quote, edge of our observable universe, which is around 90 billion light years away from us, or across rather. And it's expanding some parts of it faster than light relative to our position. And if you've ever heard of like multiverse theory or multiverse hypothesis,
yeah,
an explanation for that would be outside of our observable bubble would be other, quote, bubble universes that would have their own set of stars and galaxies, but it's outside of our observable plane, so we can't know about them, making it in essence another universe.
So that is an interesting take on the multiverse concept, because the way it was always described to me was like there's some sort of border within these quote unquote bubbles, right? That there's something that kind of separates the bubbles. But what you're kind of describing them more as observable bubbles or like visual bubbles, in the sense that like, well, anything living within that universe, that's all that it can experience. Like that is its boundary of observation.
Mm-hmm. Yes.
And that is, to me, it's a little bit more believable and understandable. It's easier to digest the idea that, well, within any, like, let's assume that there's other intelligent life out there that would be beyond the edge of our observable universe. Our observable universes could technically then, under that explanation, they could overlap quite a bit, but our specific points of observation don't fall within that overlap. They would fall outside that overlap. Therefore, we would never have any sort of knowledge of or interaction with that other hypothetical intelligent race.
Yes, and another scary fact that's kind of related to that, at some point, all the local galaxies around us will have expanded so far beyond our vision that our own galaxy will appear to be the only one in the universe.
Mm-hmm. Yeah, that is trippy.
Yeah.
Now it gets...
we live in a very interesting time that we can study these other celestial bodies, because at some point that will not be a possibility.
Yeah. Ascalon, what is your thoughts on that? Like, I see you nodding, and it seems like you're thinking about it.
To be honest, it's all kind of mind blowing. It's as you said at the start of the episode, it's so hard to get your head around some of these concepts, but just because of the sheer scale of them. I've no doubt that Kyle's done his homework. I'm just going to have to take his word for it in this front.
Yeah, that.
Go on, Laura.
No, you go ahead.
I was just going to expand on what Raymond said about it being mind-blowing big. Even when we're talking about, when we get to these like crazy concepts, because they're that far away from us in time and space, I think sometimes we forget even the most kind of, as we said at the top of the show, even the most basic distances are vast and almost on our tiny human scale, almost incomprehensible. Just the distance between us and the nearest star. It's from a human scale, it's ridiculous, and there are tens of billions of these things. The whole thing is just, I love it. It's kind of it's trippy, but it's also science in a really good way, rather than just making shit up about like taking ayahuasca and experiencing God, which sounds all trippy and sciencey, but it's just bollocks. This is actually trippy and sciencey.
This is where real transcendent or existential feelings come in. Real
genuine science, and at the same time, to even begin to get your head around it is just mind-blowing.
I mean, even if you look sorry, Kyle, if you look even closer to our solar system, like what you were saying earlier about how big the Earth is, that people don't realize, I think you can probably correct me on the numbers here, Kyle, that there's like 1.3 million Earths could fit inside the sun. Maybe just under 1 million if you did it edge to edge.
Well. You see, I made a video about that, and I made a mistake.
Oh.
Turns out there's actually another video on this. Not 1.3 million Earths can fit in the sun. It's actually more around 700,000 to 900,000 because of the way spheres stack.
Yeah, it's tiny then, obviously.
That's
and that discrepancy, honestly, like it's a relatively small discrepancy if you're thinking of, well, did the person who calculated the first time, where they talk about the volume of the Earth versus the volume of the sun, and how much, if you liquefied the Earth and poured it into the sun, how many Earths could fit in there? Or was it like what you said? Yeah, so it's interesting that there are different ways of measuring or like coming up with these numbers. So yeah, if you kept the Earth as a circle and stacked it like marbles inside the sun, obviously it would be a lot less. So
about 700,000,
which is still freaking mind-boggling.
Yeah, because we can't even friggin' picture the scale of our Earth alone, let alone a number like 700,000. That's just not. You can't conceptualize that.
No, you can't. That's what I mean. It's just craziness. The other thing that really bends my mind is pulsars as well. I've sort of looked into them a little bit. I understand very little, other than it's probably the only known thing in the universe that's faster than a Scotsman that's just dropped a penny.
Well played. Yeah, I'm starting to learn little tiny bits and pieces, which leaves me actually, the Dunning-Kruger effect, where when you start to learn something and you think you're smart on it, you actually rate yourself as being smarter than you really are. With that in mind, like I feel like I'm starting to learn a lot about astronomy, but then when I go to like vomit it back up for an audience, I'm like, oh God, I don't remember any of the numbers, I don't remember any of the specifics, which is very humbling, and it reminds me just how quickly we can espouse like a certainty in knowledge, but then really have no idea what we're talking about. So
yeah, I mean, I have that feeling all the time where the more I learn, the more I understand the depth of my ignorance. Like, sure, my pool of knowledge expands, but I'm able to see the depths of the bottom more clearly, and I realize, oh shit, I'm
barely scratching the surface.
There's so much more to learn. Yeah.
And what he was.
That's a great feeling. I don't want to go off topic too much, but that's a great feeling, though. That feeling of You know, I'm never going to know everything. I kind of, my specialities is in like looking at early scriptures of but I don't just do it of one religion because I'm greedy. I do it of Islam, Buddhism, and Christianity. And like I've been doing that for seriously 10 years, and
Yeah.
I'm still scratching the surface. Still scratching, and that real when you get to that realization, you're never going to learn everything there is to learn. It's a fantastic feeling. It's a fantastic
truly
feeling.
is.
And
Oh, yeah.
That's part of my whole secular spirituality thing, is that feeling you get from understanding how much you don't know.
Or
Yeah.
in discovering something new. Like when I learn something new that I've never learned, especially when it's something super mundane or something that I've been exposed to over and over again, it's a new knowledge of it or a new perspective of it. I get this feeling, it's almost like a glee, right? It's almost like when back when I was religious, and I'm sure there's other religious people who can kind of empathize with this feeling, like when someone translates a scripture in a specific way that it resonates with you, like, oh, that makes that scripture more true, or that validates my religion even more because that makes more sense. It's there's this feeling of happiness or glee, and that's kind of what I get like when I discover it could be super super mundane. So then it gets even more and more and more exciting as the knowledge gets more complex or the topic gets more deep, right? So yeah, I think astronomy more than most other subjects is that for me. Astronomy has that depth of knowledge that is so vast, and that's the little bit that we know about it.
Yeah, and of course, the great thing about it is that, I mean, I know we've mentioned this a couple of times, but it's not just one discipline, and we're still learning so much about our own solar system,
Yeah.
as well as the deep. I mean, as much fun as it is to talk about the deep, like dark depths of space, there's still so much we don't know around the corner. And that it's in itself is fascinating. I mean, we've just sent a rover to Mars, learning new things.
Yeah.
And you know, this so much astronomy gives us so much to kind of take in, and you could really just pick one tiny, tiny, tiny area of it and spend a lifetime studying it and still not know all there is to know. And of course, it's an area where there's new discoveries as well that come up and new ways of investigating and things. So
It's an
really interesting.
interesting discovery. What I wouldn't say I call it recent. It was like 2009, if I'm remembering right. The sort of astronomers found like there's a big cloud of gas and dust, sort of almost roughly at the center of the Milky Way. It was what was the name of the chemical? It was ethyl formate. It's got two very interesting properties. It's responsible for the smell of raspberries and the smell of rum.
best smelling
Wow.
best smelling spot in the galaxy then.
I'm gonna have to do a video on that.
That is super cool. Yeah, I look forward to that. That would be fun. Yeah, something that Richard said made me think of this, but well, and going with like the edge of the universe and known universe and all that other stuff as well. Um, talking about not knowing what we don't know, what really like blew my mind was that when astronomers had first pointed a really really high powered telescope, probably a satellite, out into what they thought was an empty part of space, right? So like, okay, nothing there, it's totally black, we can't see anything, let's take a picture of that, right? And what they got back was just myriad, like just galaxies, like that space was full of shit. Right, we just couldn't see it. And that to me, now we kind of take it for granted because we look out into space, we have these pictures of space, and we kind of have this idea of, oh yeah, there's a lot beyond our galaxy, there's lots of galaxies. But to be that first person that pointed that telescope at that empty little space and didn't know what they were going to get back, right? And to get back like
I
all
don't
this
think people now realize what and I don't know if we were speaking about this specifically, but I don't think people realize now what an achievement and what a revolution the Hubble Space Telescope was when that went up, because that changed everything as far as deep space astronomy goes.
Yeah, it's definitely knowledge we take for granted, huh? That didn't exist like just a few decades ago.
I mean, here's a really like interesting fact for you. If you hold your hand out at arm's length and just trace out the line that your thumbnail makes, that little space in the sky holds millions of galaxies. You know, you can take the full moon, and just that little space that the moon hides behind it is millions of galaxies. Like
Yeah.
there's so much out there. And I think this is one of the best. Maybe I'm biased, but it's one of my favorite, and I think the best fields of study is astronomy. Is the study of space, because God, there's just so much out there that can make you feel one connected with your planet. I get this great sense of connectivity by studying space, by studying our origins in space.
Yeah, it's funny because like the rhetoric that I heard a lot when I was religious was that, well, if we're just a speck on an arm in a galaxy in the middle of space, we're insignificant. And I kind of bought that at the time. My take on it now is, yeah, we're pretty fucking insignificant. We are. We're a little speck on a little arm in a little galaxy among billions, trillions, who knows how many galaxies, right? In a universe that we can't even begin to comprehend the size of or the true scope of. Yeah, we're pretty insignificant. But
that's not a bad thing.
That's not a bad
Not
thing.
at all.
No, that is still freaking amazing. That of all the places in space, here we are. This is us. Like we evolved into this.
And I mean, and then we get to share these experiences with great friends. It's such a cool thing.
Yeah.
I mean, who needs religion when you have a conversation partner and the universe to look at?
And that's not to discount religious people from being interested in astronomy or space or
Absolutely
anything
not.
like that.
Yeah.
Because
Oh, of course not. No.
a lot of them are, and I suppose it in a weird way for them, Kyle and Laura probably answer this firsthand, having been religious. Ascalon, you've never been religious person, have you? As far as I'm aware.
No.
So
Church of Scotland's pretty much the wet fart of religion in this part of the world. It's largely inoffensive.
Kyle and Laura will probably able to know what I'm talking about firsthand, but I'm looking out at the vastness of space as a religious person. I'm sure that reaffirms your faith in it when you're coming from that perspective, because you're looking at it and you're saying,
sure.
look at this, it's
Absolutely.
the glory of God that, manifest.
Yeah, for me, it was just like, well, God must be even more powerful than I can imagine to create all this. And it's just, I mean, what else could? It's the argument from ignorance. What else could have done it?
Yeah. And there's a lot of it works both ways, right? There's a lot of glory to God because of the vastness and incredibleness. But then there's also a lot of like back engineering, like, okay, well then if the universe is this old, how could God have possibly done it? And then that again reaffirms how powerful God is. Oh, well, he could have easily put us on a planet and created us and then boom, stretched out the universe around us, right? And it could have easily been like something that he appeared to make it look billions of years old when it isn't, or whatever, or he was the one that moved these things into these places, so and stretched the light to come to reach Earth so that we could see these stars. So then it becomes an even greater testament to God and how infinitely powerful he is.
It's funny how these religious ideas never existed before the science managed to be there. I know there's a lot of people in Islamic apologetics talk about how the Quran spoke about the Big Bang and stuff. Yeah, it's funny how none of them actually gave a detailed description of it before it was discovered, and actually discovered the Big Bang themselves based on the writings of the Quran. They fit it in retrospectively when the science has been done to try and affirm their religious beliefs.
Yeah.
Is that called ad hoc rationalization, or is that something
Post
else?
hoc.
Post hoc.
Yeah, ad hoc is on the fly and post hoc is after the fact.
Got it. Thank you.
Yeah.
So let's get back to astronomy then, and let's get back to near Earth astronomy, seeing as that was kind of the jumping board we went from. If you had and this goes out to all three of you, and I'll answer it as well. if you had the chance to closely observe and learn as much about anybody in the solar system, which one would it be?
Easy.
Ooh. You go first.
That would be the moon Enceladus because of its immense ocean underneath the icy crust.
Yeah. Oh, and the potential for life there, right?
Yes, because it's been heated
Yes.
by now you're gonna look at me like, Kyle, how dare you? But I'm forgetting if Enceladus is a moon of Jupiter or Saturn.
Oh my God, I don't want to say.
I
am
thought
I don't
it
wanna
was
guess wrong.
Europa that had the
Europa. That's one of them. I'm pretty sure Europa is Saturn. No,
Europa's Jupiter.
Jupiter,
Yeah.
yes.
That was, I mean, we're going back, I'm going back 20 years here when it was kind of speculated that may have an ocean. Has that changed? Oh,
No, it's even more confirmed now that Enceladus
right.
does have an ocean underneath its icy crust that's much, much deeper than our oceans here. And the cool thing is it's actually been heated up by gravitational friction. The planet is so massive that the moon is being caught between its gravity field
It's
and
the tidal
causing
forces.
yeah, the tidal force is causing it to like stretch out. So it's got a heated ocean underneath this icy crust. So there could definitely be life down there, and I would love to be able to go study it.
Is it the case? I'm going to come back to Laura and Ascalon with that question just briefly. I just want to ask you on that point. Is it the case that the gravitational pull, I think it's Jupiter, is so massive that one of the planets actually bulges like that just because of its gravitational pull on it? It actually changes the shape of the planet.
Well, the moon is lemon shaped.
The moon,
yeah. Am I right in thinking that, Kyle? I'm sure I read that somewhere.
That's not something I've heard, but you might be right.
I don't know. So I did cheat and I looked it up, and Enceladus is a moon of Saturn.
Saturn.
Right.
I will not forget.
Yeah, so Europa is Jupiter and Enceladus is Saturn, but the same basic concepts of encased in ice and more than likely has an ocean underneath.
Okay, so Ascalon, favorite.
Neptune, hands down. It's one of those. It's quite a banal thing, but it really fascinated me when I first read about it. Is it gives off more heat than it takes in from the sun, and nobody knows why. I think, much like Kyle, it's something I would really like to go and find out what the fuck is going on there.
Interesting.
I thought you meant much like Kyle, it gives off more heat than it takes in. I thought we were returning to the subject of Kyle's chili again.
Side note, I am making that this weekend.
Ooh.
You have to send us more photos to make us incredibly jealous, seeing as we're an ocean away.
You know, he did post the recipe, so if you follow him on Facebook.
I keep tweaking the recipe a little bit.
I do that with my recipes too. We're getting way off topic now.
Yeah, sorry.
Laura.
Yeah.
Laura,
okay, so I'm one of those
body.
people. I'm gonna give a non-answer. So my kids ask me a lot, like, what's your favorite this or what's your favorite that? And the way my brain is wired, I don't really have favorites. So it's hard for me to answer that question. But two things that fascinate me that I'd want to know more of. I can't narrow it down to one necessarily. But Venus and Jupiter, and for two completely separate reasons. They're both very gassy planets. But Venus has more of a makeup that's similar to ours, right? In terms of it having a solid structure underneath and then a gaseous atmosphere, a really dense atmosphere. So I'm curious to know in which respects Venus is similar to us and in which respects it's different, and whether or not it's possible to, like, we have extremophiles now here on Earth, which is like animals that can exist in incredibly extreme environments. So is it possible, my question, to have, like, say, microbes or some microscopic organisms that exist within the atmosphere of Venus? And I know the pressure is so intense getting down toward the actual surface that I don't know that a cell body could maintain structural integrity on the surface, but floating up in the atmosphere, certainly it's a possibility, right?
That has been studied, and a lot of conjecture has come
Lots
up
of
about
hypotheses.
it.
Yeah.
The thing is, it's so acidic that the molecules may not be able to come together to form in the first place.
So the cell, yeah. So it all comes down to like cell structure and stuff like that. Is it an environment that will allow for cells to develop? and evolve. And so yeah, maybe that already answers my question, but
Yeah,
even then, like even if life isn't possible, just knowing more about Venus and its history, even like how it can be so close to us and yet so chemically different. And Mars is the opposite. Other than not having an atmosphere, it's very similar to us, and it very well could have potentially supported an atmosphere in the past. There's a lot of evidence that it did once
yep.
have an atmosphere. So Mars and
And
Earth could have
ocean.
been, yeah. There's a lot of there's even, isn't there still water on the caps of Mars? Like don't they have like they
Frost, I
have
think. There's a couple of different forms of water on Mars.
yeah. So Mars and Earth are very similar, like twinsies, but they've had something happen in the past to make them um, go two different paths. And then Venus is also a hard, rocky planet, but it's very, very, very different from Earth and Mars in terms of like its atmosphere and stuff. So that interests me. But then Jupiter, I heard like a really out there sort of theory in a documentary I watched. I don't know in the scientific community how much clout this theory has, but I heard that most star systems are binary star systems, and that we're
Mhm.
actually unusual and that we're not. And there's a theory out there that Jupiter is actually a star that failed to form, like something happened with the chemical um reaction process where it just didn't fire off and ignite and didn't have the same, I don't even know what you would call it, like processes at the sun. It like puttered
It
out
didn't go.
basically.
It didn't undergo nuclear fusion.
Thank you. That I was struggling. Yeah. And I would love to know more about Jupiter and whether or not it's a potentially like our star's binary failed star.
Well, you would need several masses of Jupiter put together to create a star. There's Jupiter's pretty far away from a star. It's more of an exaggeration when people say that it's a failed star.
So is it just like one of those like hypotheses that got thrown out there? And so these are all things that I just hear and I don't really like study or know about, but um yeah. So what would be the reasoning for throwing out a hypothesis like that, or what is the
It's a good question, actually.
yeah. And we don't have to have the answers, but those two fascinate me. All the planets fascinate me, but those two are the ones that like those questions are off the top of my head.
Well, if you like Jupiter, you probably already know this fact, but Jupiter keeps us relatively safe from near-Earth objects.
Yes. Yep.
It's
Yeah,
kind
they're
of
the
our
reasons we don't have more.
I remember when, because I'm old, I remember when Shoemaker Levy 9 hit Jupiter and the kind of the A, shockwaves, and B, fascination that went round the world due to that. If there are any kind of younger people watching or people who aren't aware of what it is, in the 90s, I'm not sure what year it was, the 1990s, a comet went past Jupiter and broke up and actually smashed into it. And I think, I don't remember, there were 5 impacts for 5 different pieces of this comet, and each one was the size of the Earth.
Oh,
It had
wow.
completely obliterated us. If it had hit us, we'd have just been obliterated. And it broke up in Jupiter's due to Jupiter's massive gravitational pull and got sucked in. And the images, you actually saw the impact one after the other. They filmed it. Actually filmed it. Go and look it up. Comet Shoemaker Levy 9, and it was an amazing thing. It was fantastic. But yeah, Kyle's absolutely right. It's like having a dog in your yard protecting you. It's
Only a really, really, really big dog.
really
Dog
big.
would be bigger than your house, technically.
Yeah. Yeah.
Yeah. So my favorite astronomical body is well, not favorite, but the one I'd like to see study, like lots more study on, is Pluto. I think Pluto was, and again, I remember this happening when it was declassified from a planet to at the time
Thanks,
a
Neil deGrasse
planetoid.
Tyson. No.
I don't know if it's I don't know if it's been reclassified since as something else, but it was originally declassified from a planet to a planetoid. And it's at the time when that happened, it fascinated me that they reclassified things in such a manner anyway, because I wasn't aware that happened. I thought when planets were named, that was it, and classified, that was it. It turns out that's not. Things change.
Yeah.
And I get this. impression that because it's no longer a planet, there's not as much interest in it as there once was. And I love an underdog story.
Oh, and I wonder if that's in the scientific community or pop culture, because scientifically,
I
think
don't
they
know.
just had a what do you call those things, like a probe that they shot, and they got images of Pluto. So I know that in the scientific community, they're still
it's gonna
super
be a
interested in
pop
it.
culture thing,
Yeah.
but yeah, I want to.
I mean, keep in mind, Pluto is 5 times less massive than our moon.
Yeah, it's tiny.
Yeah.
You know, it's small, and it does fit the category of all the other icy bodies out there that look like Pluto. So to categorize it with them just makes more sense.
And it's in the
And
same kind of
that's
zone as them. It's just on the inside of that. What's the belt?
the Kuiper belt.
Kuiper belt. Yeah.
Yeah. What's
And
the one
this
between
is coming from
Mars?
somebody who loved Pluto. So
And you know, you
What's the belt?
reclassify something, doesn't mean you love it less.
What's the belt? Is it the Oort cloud, the one that's closer to us, that's near Mars? The
No,
asteroid belt?
no, the
Or is
Oort
that the
cloud
further
is-
one out?
That's way out.
Yeah.
It's
Anyway,
about I think it's about a light year
We're-
sized bubble.
We're coming to the end of the show, and I might as well end on the lack of knowledge that I started the show with.
I love it. Well, the point of the show isn't to learn necessarily, it's to get curious and to start asking questions, right? And I think we've certainly done that. So we do have just a few minutes left before we close up, though, gentlemen. So what are your guys' closing thoughts? I'll let you guys fight for who gets to talk. And well, you'll both get a chance to talk, but who gets to talk first?
Go ahead, Ascalon.
Space is fucking big.
Bam, there you have it.
It's proper science right there.
And it's not untrue.
Exactly. You can take that to the bank.
You know, space is huge. It's an absolute marvel. If anyone out there has any interest in this, just go wild, study this, go down the rabbit hole. It is worth it. And above all else, keep looking up.
I love it. Yeah.
Yeah, I'm just gonna kind of echo what Ascalon said, and you know, and refer back to the Hawkwind song. Space is deep in metaphorically and physically, and I've always been I don't know a lot about it. I'm not an expert on the subject by any stretch. I'm not even an amateur on the subject. It's one of those things where I'm happy to be ignorant and just revel in the fact that it's there and we've got access to it and we can learn about it. It's a fucking beautiful thing.
Oh,
Laura, final word.
I'm not gonna take the final word. You guys have lots, and I really appreciate you guys being on. I just want to thank you guys for the time that you've spent last week and this week. Both episodes were phenomenal, and I'd love to keep working with you guys in the future. I also really want to thank our listeners, because without them, there wouldn't be an us. So thank you guys for listening or watching if you watch on YouTube. Thank you for supporting us on Facebook and keeping the conversation going. If you're not on Facebook, you should. It's good conversation just to keep it going and to take what little we talk about in this quick hour and really expand on it over the next week or weeks, as sometimes we get posts that are for older shows. So yeah, thank you guys all. We will catch you next time. In the meantime, I am Laura.
And I am Richard.
And we have with us Kyle and Ascalon. Oh, go ahead. You guys take it.
I'm Kyle.
I'm Ascalon.
Awesome. We'll see you guys next time. Bye.
See you later.